I'll start. AI is not just creating, increased demand for data centers. It is actually changing the physics, the economics, the design logic of how the new data centers are getting built now. So rack densities are exploding significantly, power demand is surging, cooling technologies are changing, and how the building infrastructure is being built right now is also evolving to keep pace with all of this, right? So the shift has created now, we believe, a level playing field for India at a global level to build greenfield data centers that can match the next era of the AI demand. So real question today that we are going to explore is, how do operators design and build AI-ready infrastructure that is simultaneously high-performing, energy-efficient, commercially viable, and fast to deploy? And I am pleased to welcome Mr. Hemant and Mr. Harsh here today to share perspective on this topic. Let's start our discussion with what is actually changing. When fundamentally AI enters the picture, what does it mean in terms of changing rack densities? What is customer actually demanding right now? And how that demand is going to evolve in the next 2 to 3 years? Uh, Harsh, we can start with you.
Yeah. Yeah. So good evening, everyone. So it's no longer about just densities, right? We have to look for the cooling as well. So density, as and when the density increase, the cooling demands also gets changed. So whenever we talk about higher density servers, we have to switch to liquid cooling, and that's where the problem comes. So liquid cooling comes with its own challenges. You have to increase the floor loads, and yeah, of course, the higher density the servers, it requires heavier the floor loadings. So current buildings which we operate for the regular data centers won't be sufficient to operate the higher density racks in future. So that's the major challenges as an industry we face today.
Right. And Mr. Hemant, do you want to share how the load densities are evolving right now in the industry? And what is customer asking for today?
Yeah, just to add what Harsh was saying, uh, earlier data centers, maybe 2, 3 years back, we used to have, let's say, 50% space as a white space or 60% space as a white space, and rest 40 to 50% space as a electrical and cooling infrastructure. Today, that ratio has changed. About 70% of the space is going into the electrical and cooling infrastructure, and around 20 to 30% space is remained as a white space. That is the change of the dynamics has changed. Of course, the load, what you say, the floor loading factor, the floor loading factor has also gone very high. We used to design floor loading for 1500 kg per square meter at one point of time, maybe 2 years back. Today, it has already reached 2500 kg per square meter. Now it is going up to 3000 or 3500 kg per square meter. That's where the major changes happened. The buildings have become heavier. It has become more denser from the MEP perspective. And of course, from cooling perspective, it has shrunk, and because of the electricity demand, in a smaller footprint, the demand is gone suddenly up. And that basically also has that certain heat island effect. And that also has to be sorted out when we see the suddenly, let's say, instead of 20 megawatt, now we have to cool a building of 100 megawatt within probably the same space or maybe 1.5 times space. So this is where it is. From a rack perspective, coming to your second question, from a rack perspective, I've seen we used to have around 5 to 10 kilowatt per rack density about 2 years back. This situation changed. Today it is 20 to 30 kilowatt per rack, and it is a hybrid. So from air we have shifted to hybrid, and the ratios are basically 90 to 95% liquid cooled and 40 to 50% air cooled. And this is where the customers today don't know what directions they're going to take, what their direction their business is going to demand, so that flexibility comes in. But what we are also seeing is that slowly, the new chips which are being brought in the market, they are going towards 90 or 95% liquid and only 5 to 10% air. And I don't see why it cannot happen in next year. So this is where we are from the rack density perspective. So I think one more things to add. So today we are about 40 to 50 kilowatt per rack, and I see that going to 100 very soon.
Realistically, we may reach 100 and then even more from there on.
Even
Right.
more from there on. It all depends on
Right.
the
2 to 3 years down the line, we will reach 240 kilowatt to 250 kilowatt.
Yeah. So when we are building now, if you think about traditional designs, Mr. Hemant, if you would like to share some thoughts on how and what part of these legacy designs will break first from 50 to 100 to 200, and then what kind of innovations, say liquid cooling, intelligent power distribution systems, thermal management system, which kind of innovations will have greatest impact in that design? And is India right now truly ready to kind of adopt, pay, and invest in those design concepts?
So from a design point of view, there are a lot of changes which are happening. The major change which has happened, of course, apart from being electrical heavy infrastructure, the whole shift has happened in the cooling side. We are no longer using the similar chillers and the temperatures what we used to have in chilled water temperatures, supply temperatures, which used to be around 20, 21 or 18 for that matter. Now this is going up to 28, 29. And what we are seeing now, chillers are reaching the thresholds, and now there are new generation chillers which are coming in, which are going beyond 30, 32 temperature from a supply side. So apart from that, what we are also seeing is as the temperatures requirement by the servers are going up, see liquid temperature, my first customer came in and he wanted 26. That means the air cooled, the chiller water temperature still remained 21. Now the customers are coming and saying that I want 32 to 36 as the liquid temperature, technology water temperature, and that brings me the chiller to be around 28, which is a good problem to have, but it also changes my the chiller design, my cooling design. The cooling towers have come in, the hybrid cooling towers have come in. The whole design of the data center from a cooling perspective undergoes a change. So there are a lot of things which are happening, which we will be adopting. However, these changes are happening not in, let's say, 3 to 4 years, or the duration between the change is not 3 to 4 years, it is just 6 months. So what I designed today or 6 months back, it's no more relevant. I have to keep evolving and making sure that my design, my civil designs, because civil construction happens first, MEP happens later. So my civil design is capable enough to adapt to the new technologies which are coming in to cooling, and therefore I will be still relevant when I get a new customer after 1 year. So this is where, from a design perspective, I see the major change which is happening. On the cooling side. On the electrical side also, the loads are no more constant loads, or they are no more changing as per the season. They are changing every day. They are so dynamic. There are many transients which are there. There is a continuous waveform of AI workloads, whether it's a training or inference. It changes as per that. However, there is the load, actually what my customers are telling me is that they will be somewhere between 80, 85 to 90, 95% continuous load. Of course, it will vary every few seconds, and it is going to be very repetitive in nature. So this is where we never witness that load goes beyond 70% of the data center capacity, ever. Here, the load every day goes to 90-95%. So your infrastructure is not designed for one-off event. Your infrastructure needs to be designed for the extreme event that will happen in a peak summer, in a peak hour. You have to deliver 90 to 95%. And of course, demand for those transients electrical loads also have to be met, and for that, if required, we have to put a battery energy storage. So these are the few things which have changed fundamentally in the data center designs.
Makes sense. And Mr. Harsh, if you would like to add a little bit on the point that Hemant ji covered, that the civil comes first and it has to be adaptable, and then MEP comes later. So what kind of civil design changes that are coming in the industry that will help that flexibility?
So if you take an example, right? So currently the next generation NVIDIA racks are 250 kilowatt, and the upcoming after that they will launch NVL 576 that will close to 600 kilowatt. So one rack can do work of 3 racks. So we'll have less white space, but the utility space will be extended, as sir said earlier. The major shift is coming in MEP and the cooling technology only, while chip companies will keep increasing the GPU or CPU densities. So we are working closely with OEMs like Delta, Schneider and all. So now they have come up with a solution called 800 VDC architecture, so where your UPS panels will be connected directly to the grid, where 45% copper reduction will be there overall in the system, where it will gain the efficiency. And the serious issue with the AI or high density computing is that whenever the inference load go up, it can reach up to 150% for a milliseconds. At that time, there is a chance that your system could get tripped. So this OEMs are coming up with graphene capacitor technologies, where your UPS will handle those load in a micro 2 milliseconds, and system will perform stable. And the same time, cooling has improved. Like now we have reached up to 3 megawatt cooling CDUs that are there. Of course, we will design it in a redundant way. So, and yeah, earlier glycol was mixed around 30 to 40%. Now we are coming with a 100% glycol system. So water is overall reduced from the system as well. So that is in terms of sustainability, it's good. When we adopt 800 volt direct current, we can accommodate up to 1 megawatt rack in a same architecture system. So the upgrade cycle for the electrical overall electrical system will be less. So in a same investment, you can upgrade up to 1 megawatt. That's the key benefit we will see in the upcoming time. And the same thing will happen with the cooling as well. So major challenges for the inference load will be covered with this technology. So that's a major shift. Civil, the load thing we have to make sure, because Vera Rubin is around 4 tons, AMD Helios is 3.5 tons per rack. I'm talking about per rack. You put around 500, sometimes 1,000 racks on a floor, so you have to calculate that load. The Kyber rack is coming is around 5.5 to 6 tons. So yeah, that will be a big challenge for sensitive zones. Like in India, like we reach to up to 5 zone 5 seismic zone. So those buildings will require specific technological advancement, as well as I will say research too, for to accommodate these racks. And of course, the cooling infrastructure is mounted on a ceiling, most of the place. So the dual load on the rack and the cooling mounted, ceiling mounted cooling rack, cooling equipments, that will we have to consider. Otherwise, none of the buildings will be accommodated to, will be available to accommodate the next generation racks.
Right. So then it seems like what we are designing now may or may not be relevant few years down the line. So these are the intelligent and smart design choices that we need to make today so that our infrastructure does not become obsolete in the future. So any specific thoughts on how the industry is kind of tackling that problem of what we can do in the design choices today so that it stays relevant in next few years?
So generally, data centers are designed based on the use case of next 15 years. The client contracts are generally stays there for 5 years to 15 years. And a life cycle of upgrade is around 5 to 7 years. So whatever design choices we make today as per the client will remain there for minimum 5 years. So these all technologies are for HPC and AI. While we have another universe called co-location, where rack density start from 8 kilowatt to around 25 kilowatts. You take any enterprise or banking, and their maximum load is 50% most of the time. So those will not have a radical changes for at least 5 to 7 years. But wherever the enterprise is adopting AI, or even finance institutions are adopting AI, they will have to adopt these new technologies. Otherwise, their data center won't be relevant.
So in that context, Mr. Hemant, are we looking at new greenfield deployments with the new design setup in the future? And how is India placed to kind of drive that wave? And are we ready in terms of doing that innovations in India?
Yes, I mean, we need to see the next 2 years horizon, what kind of chips are coming, what servers are going to come, and it is publicly available information. And as long as you have built your data center to meet those demands. So what is changing specifically, if you see, the heights of, apart from the weight what we talked about, the height, the floor to floor height is changing. So as long as you're able to accommodate the power infra as well as the fiber infra on top of your rack and liquid cooling as well. So as long as you're able to accommodate that, you will still be able to meet the future demand. But it cannot happen that earlier the data center used to be, shell was to be, used to be built one this year, and the whole data center used to be phase-wise commissioned in 4 to 5, 6 years period. But now it is no more like that. The customers are asking for data center to be delivered within 15 to 18 months in one shot. That means all the data halls together. And therefore the rapid income, servers are also coming in that fast. And the whole data center becomes operational, let's say within 2 to 3 years period. So only the problem will come when there is a refresh coming in. At that point of time, we don't know. I mean, there is no such prediction which is available what is going to come. But yes, one life cycle of the servers we will be able to meet. Next life cycle depends on what is the requirement. That's how we have to look at it from perspective. Of course, the rack density is going to go up, so there is, as long as you are able to meet power and cooling, your data center space will shrunk only.
Interesting. And you mentioned a very important point about the timelines, right? So demand cycles are compressing, and the deployment timelines that customer are expecting is shorter and shorter, right? But uptime, efficiency, other parameters remain now non-negotiable as customers demand, faster cycles, supply cycles. So the question is that whether the industry can move at that pace without introducing any other hidden risk that could, expose industry. We are talking about prefabrication, modular designs, digital intelligent systems, etc., to speed up the deployment process. So realistically, Mr. Harsh, the question to you, how much realistically these concepts can help reduce the deployment timelines in India?
So basically, this modular approach, if you go for a construction, that is not viable for India. That is what my opinion is. we have challenge of cyclone, extreme heat and all. So modular containerized data center and all solution won't work. But specifically, if you go, like we can build a prefabricated substation, we can build a prefabricated UPS and transformer rack, integrated transformer rack. Those solutions can do FAT at the manufacturer's location, and at our data center location, we can just do the SAT. That saves a lot of time. Yeah, so in a way we can save the time, but in a construction, only precast can be adaptable for our country. Otherwise, containerized and all solution will remain limited to the edge data center use cases only.
And Hemant, do you want to share some thoughts here?
Yeah, obviously at this scale and this speed, it is humanly not possible to build every data center differently, nor it is possible to get thousands of labor at one place. There is a safety issue. Of course, that doesn't work. So going forward, the prefabrication is the key. At the factory premises, we need to develop those kind of vendors. They need to be tested good enough. In fact, what I see is that apart from the data hall, everything else can be standardized in a more Lego kind of blocks, whether electrical or mechanical infrastructure, can be built in the factory, tested, brought into the site, connect together, and do a commissioning. I think that is the way forward. There is already, this is not a new concept. This has happened in other parts of the world. In India, somehow we have not been able to develop that kind of ecosystem. However, this is catching up at Adani. We are already tried many of the factors. We are also trying the DFMA that is designed from MAP frame, designed for MAP frame. So that also is another technology where all the MAP infrastructure is also prefabricated, assembled at different site, which is near to the site in the factory, and then brought it to the site, and then just lifted to in place, and then connected together. And I think that is the only way going forward. But for that, this standardization is very, very important. So we need to basically have those Lego blocks created, which can be used from one operator to another operator, which are similar in nature. And if we standardize our designs, or if the designs are certified by some of the hyperscalers, it will speed up. So only standardization and the is the key forward, moving forward. Of course, precast we are already doing. So civil side, we still firmly believe precast is the way forward. It is way easier. It is quality-wise, there is no compromise on the precast. It is easy to put it aside. It is safer to construct, and it is faster, and it is reliable. So we are already doing it at most of our sites wherever it is possible. But as he said, Harsh has already said that there are the other technologies or something which we are not able to catch up with.
Interesting. And how do you think is AI helping design efficiently and deliver efficiently? Concepts like digital twin that we just spoke about in the previous session, AI-led operations, are those also relevant at the design and build stage? And how these concepts are increasingly emerging in India? Are we ready for it?
On a software, to ensure that whatever we design today becomes relevant with these changing workloads, changing demands, even changing the technology with new servers coming in. And it is going to be how do you adapt the physical infrastructure to the new AI servers? It's like that. So you simulate that and you see where are the problems, you solve those problems, and with AI it is possible. So it is not only the simulation, it is predictive fault analysis. What I'm seeing today, there are very few, not all components of data center are addressable components. So Only few equipments are addressable, not everything else. But going forward, we have to make every component of an equipment addressable so that all the data comes in and the data is analyzed to predict the faults. Data is analyzed to predict the performance, and data is analyzed to give you more visualization in what's happening inside your data center. And once you get that visualization and you run automation on top of that, we can create a build cases where systems can run more efficiently without much intervention from the humans. So I firmly believe that digital twin is the way to go forward. We still are in the experimenting stage, and that is where we have to make it successful.
Yeah. So for digital twin, there is a solution from NVIDIA called Omniverse. We are trying it for our Kakinada site, where you can simulate your entire data center even before construction. And there is a software called ETAP, where you can simulate your electrical loads and what if scenario in all the conditions that can happen in a typical life cycle of a AI or non-AI data centers. And we have called Cadence. Cadence can do CBD, CFD analysis for cooling and heat spots and all. So those analyses you can do even before installation construction. And yeah, we have a Airlink software that you can simulate your network load and all. So all those tools are available readily, and we can play around. And now has reached to a perfection level where they are also taking the data from that current data centers and training their models. And yeah, it is near perfect. We can do that in digital twin, and same digital twin we can transfer it to our BMS or IDVMS, and then we can start monitoring particular data centers.
Interesting. So it looks like there is an end-to-end solution in the industry right now, and India needs to think about adopting it.
Yeah, just to add what Harsh has said, all the software, whether it is ETAP, Cadence, or CFD model, or any other software, we are having it for many years now, decades now. We used to use them before we construct the data center at the design stage. And not everything, the way data center is constructed is not really modeled into that thing. Now with the digital twins coming in, the as-built is also getting incorporated into digital twin. And with this as-built and the additional passive infrastructure from the server, fibers, cables, everything is simulated there, can give you more productive results and more proactive results. And therefore, the success of digital twin will actually come in.
Right, right. I think our time is up. So every design decision that we make now sits at an intersection of how we achieve performance, sustainability, economics, speed to output. And what we discussed is solutions like modular designs, digital twins, as well as rethinking the legacy design concepts into more future replicable designs could help us achieve that. So I really thank you for sharing your perspective here, and also want to thank the audience for staying with us till the end, and W.Media for organizing this event and this panel. Thank you so much.
Thank you.